Hello guys, and welcome back to a new video. Today's video is going to be on the disk and washer method. The disk and washer method is a method that has to do with integration. It is essentially finding the volume of a solid enclosed by a function. Okay, so I'm going to draw a visual diagram so that it's easier to visualize. Okay, so we have our x and y axis, as per usual. And now we're going to have some function of x, f of x. Okay, now this line, okay, this function is going to be rotated around the x-axis. So it will come out to form something like this. I'm not a very good drawer, but it is basically going to look like a smooth cone. So it creates these discs, as the name suggests, disk and washer method. It creates these discs, and they have like the length between them, okay? The width of the disc is going to be dx, okay? So they are infinitesimally small, right? Okay, so that's essentially what we want to find with this. So let's try an example. Well, no, I need to give the equation first. So this equation is relatively simple when you think about it. So we have our function here, and obviously to find area under the curve, we are going to have to use integration for that, because area under the curve here. Okay, and then this is basically being rotated 360 degrees. So we're basically going to, this is what it's going to look like. V equals pi integral from a to b, which is going to be the start and stop values, essentially, upper and lower limits, of r squared of x. Because this r squared is our function here. So in this, for this case, it's going to be f of x, okay? And then dx, obviously, as we're integrating. So here you can see that pi and r squared, well, they are obviously coming from the area of a circle, okay? Pi r squared is the area of a circle. This can be done not only on the x-axis, but also on the y-axis with something like this. So you have your axes, you have your function, but this time it's going to be measured like this, okay, and rotated around the y-axis. So this would be from, again, a to b, or you can use other variables, whatever you prefer, but it's going to change. V is going to equal the volume of the solid, is going to equal pi integral AB, but it is going to change the x variable here to a y, as we are integrating on the y-axis. So let's do that. And then dy, as it's in respect to y. Okay, let's try a very elementary example. For this first example, we're going to do y equals root x and we're rotating around the x-axis from x equals 0 to x equals 4. Okay, so first we can start by graphing. Well, that's not a very nice line. Let me just redraw that. first we're going to start by graphing the function root x. That should look like this. And we are going to draw so we can visualize which axis we are rotating around. So we're rotating around here, so that means we're going to get discs that look like this. Okay? Now, if we use our equation that we have up here for the x-axis, we can use volume equals pi root a to b r squared of x dx to work this out. So essentially r of x, right, is going to be equal to f of x in every scenario. Okay? So let's plug that in. V equals pi integral a to b, okay, f of x dx. Now we'll plug it in. V is going to equal pi integral. Our lower limit is going to be x equals 0, so 0, and our upper limit is going to be x equals 4, so 4. And then f of x squared, okay, so that's going to be root x squared. Root x squared dx. Okay, now we're going to do pi times by the integral from 0 to 4. And then what is root x squared? Root x squared is going to be x. Alright, so integral of x dx. Okay, so I'm not going to fully simplify this because I do not have my calculator here and I am not timesing an irrational number by whatever may come up. Alright, so now we're going to take the integral of x, which is simple. So it's going to be pi x squared over 2 plugged in from 0 to 4. Okay? And we don't need a plus c because this is a definite integral. Okay, so pi times by x times by 4, because that is x squared over 2 minus pi times by 0 squared over 2. So here we can see that this is going to equal 0, as 0 squared is 0, 0 times pi is 0, and then 0 divided by 2 is 0. Okay, now 4 squared is going to be 16, so this is going to equal pi 8. Okay, and that is our final answer for the volume of this solid enclosed and rotated around the x-axis enclosed by the function root x. Okay, we have rotated it around the x-axis. Now, why don't we try rotating around the y-axis, still using the same parameters, but changing x to y. Alright, so I'll also change this. Okay, now, so we've got y equals root x, but now we need to find a function of this function of x in terms of y. Okay, so to do this, we are going to need to get x by itself. We're going to do this by squaring both sides of the equation, as root x squared is just x. So that means that y becomes y squared. That is what our equation is going to be, and that is what we're going to use for f of y. Alright. So, for this, we are going to have to use this equation stated here. X equals pi from a to b r squared of y dy. Let's go ahead and plug that in. Volume, we'll call this volume 1, so it differs from this volume here. Actually, let's change this to volume 1, and then we'll change this to volume 2, sorry. Alright, so now this is going to equal, and let's plug the numbers in. Pi integral from a to b, a being 0, b being 4, of y squared dy. Alright, so first we are going to simplify this. Y squared to the power of 2 equals pi integral 0 to 4 y to the, what is it? If we use the index law, x to the n times by m, this is going to equal x to the m times n, okay? So we can use that same here. What is 2 times 2? 2 times 2 is 4. So y to the 4th dy. So now we can go ahead and we can integrate this. Pi times by y to the 5th over 5 plugged in from 0 to 4. And again, we don't need plus c, the constant of integration, as we are integrating a definite integral. So this is going to equal pi 4 to the 5th over 5, and then we don't have to worry about 0 being plugged in for y, as we know that that will come out to 0. So 4 to the 5th is, wait, let me use my calculator. 4 to the power of 5 is actually 1024, or 1024 divided by 5. Now, I'm not going to simplify this any further, but we'll leave it at this. And that is the answer for the solid rotated around the y-axis from y equals 0 to y equals 4. For our next question, we are going to do this. Y equals 1 over x rotated about the x-axis from x equals 1 to x equals 3. Alright, so r of x is going to equal 1 over x. Also, guys, if you ever want to just try the equations yourself, go ahead. These videos are mainly made to be informative, and if you're just here for practice, then go ahead. Alright, so let's graph 1 over x, and then from 1 to 3. And it is going to be rotated about the x-axis. Alright, so we'll just use our very simple formula here. Pi integral a to b, r of x squared dx. It's pretty simple, guys. V1. So this is going to equal pi integral 1 to 3. R of x is going to be 1 over x. So 1 over x squared dx. Okay? Now, we are going to simplify this expression right here. Pi integral 1 to 3, and then 1 over x times 1 over x is going to be 1 over x squared dx. And the way we can do this to make it even simpler, it's going to equal pi integral from 1 to 3 of x to the negative 2, okay, dx. Alright, so we can use our integral rule here. To simplify this, okay? So this is going to equal pi integral of, well, nope, sorry, not integral, pi times by x to the negative 1 over negative 1 plugged in from 1 to 3. Okay? So, what we are going to want to do next is just plug in 1 and 3 for x. Alright. Here we can actually shift x down again. So we get negative, and then we'll do pi over x plugged in from 1 to 3. Okay? So now this is going to equal negative pi over 3 plus, as a negative and a negative equal a positive, plus pi over 1. So this is going to equal, we can simplify this even more, to pi over 3 plus pi, which again we can further simplify this to equal well, I mean, we can further simplify this if we really feel like it, but we don't have to. Let's just do it. 3 pi over 3 minus pi over 3, okay, equals 2 pi over 3. That is the final answer. So our next and final question is going to be this. Y equals x squared. From x equals 0 to y equals 4. Okay? Y-axis. As we are going to be rotating this about the y-axis. Okay. So, the first thing we are going to do is graph this out. So, we know that if x equals 0, then y must also equal 0. So we can change this here to y equals 0. So we'll have our lower and upper limits, our function, like this, okay? And then rotating it around the y-axis. Alright, so again, we're going to need to get this function in terms of y. So we're going to need to get x equals and then some function of y. So x equals, if we take the root of both sides, we get root y. Okay, so we are going to use our nifty formula, pi integral from a to b r of y this time, squared dy, okay? So v1 is going to be, you don't have to do v1, guys, it's just that I prefer to do it in this way so that I can have consecutive numbers if I have to do more than one volumes. That's how I like to do it. So we'll just go ahead and plug in our values of a, b, and y. So a and b is going to be 0 and 4. Of y, our function for y is going to be root y squared dy. This is going to equal pi integral from 0 to 4 of y dy. Okay, so now the integral of y is going to be y squared over 2, y squared over 2, plugged in from 0 to 4. Alright, so pretty straightforward. And then we are going to plug in 4. We can disregard the 0 in this case, as it will just cause that term to equal 0. Okay? So let's do that. Pi, and then y equals 4, and so y squared is going to become 4 squared, which is 16, over 2 equals 8 pi again. So thank you for watching today's video. I hope you enjoyed and learned something new. The main takeaways from that are the two really easy formulas. V for pi integral of a to b, r of x squared, dx, and the other is when rotating around the y-axis. The integral of a to b, r squared of y dy. So those are the main things I want you to remember. It's relatively straightforward, so good luck.